Well, greetings, fellow mutants. So here we are, centuries, many generations later, and we're not cooking along anywhere close to what those who were originally created. Today I'm going to talk to you about two isotopes that point to a young Earth. Lower left, there it is. Try that. Yeah. Topics, looking at the interpretation of data. I thank Dr. Neal for his talk, because as he was speaking, I was thinking, yeah, that should show up pretty evidentially in what I have to say. You'll see the scientific method, I hope, coming forth in what I have to say. So I have some data, some summaries for carbon-14, some from xenon-129, and then some conclusions. Data interpretation depends on your personal view of Earth history, as we've heard in the two previous talks. I start with, thy word is truth. Jesus in John 17:7. That's the starting point. Of course, if you're a evolutionist, as Jerry said, first there was nothing and it blew up. Well, here we are. It all began with the Big Bang, less than 20 billion years ago, according to Carl Sagan, who's dead now and found out differently. So the creationist view that there was separation of the waters and the establishment of the atmosphere on day 2 of creation, about 6,000 to 10,000 years ago. On the other side, the Earth formed right now it's 4.57, they're refining the numbers. It's interesting. Now, I'm really a 20th century person, educated, in the last century, and that's why I'm gray. And when I was in high school, the Earth was only 3 billion years old. So the Earth has aged 1.5 billion years in my lifetime. It's just incredible. So anyway, here we are. Now that's a big difference. So you have the early Earth atmosphere being very similar to what we have presently, but there was more CO2 and more oxygen, and there's a reference for that. And on the other side, the evolutionist says, no, there was no atmosphere at all. And the current atmosphere is a product of mantle degassing over billions of years. And there's a reference for that. So here's a question for you. True or false? Coal, petroleum, and natural gas contain only dead carbon. In other words, all the carbon-14 is decayed. And it comes right out of the textbook with Farr and Mensing. This is one of the standard textbooks on isotopes. True or false? Well, the answer is false, and I think I'll hope to convince you of that by some of the evidence that I'll show you. Now, before I go on, if you're a student and you read that statement, would you go off looking for carbon-14? You wouldn't look for it in any of the coal, petroleum, or natural gas. So, gee whiz, radioactive fizz. Carbon dioxide is what you have in your soft drinks. And that makes the fizz. And we've got CO2 gas wells in New Mexico, and I went and analyzed some of them. So you say, well, why would carbon-14 be you find that in old CO2? Our view as a creationist is that the Earth is young. Carbon-14 has a half-life. Some of you may not understand half-life, but radioactive materials, they decay, and half-life is that of the original starting material, half of it will decay back to its natural state, in this case it would be to nitrogen 14, in 5,730 years. So half the amount that you start with, that would be decayed back into nitrogen 14. All right, so if you were to wait around 350,000 years and you had a sample, there wouldn't be a single carbon-14 atom left in that sample after 350,000 years. Now, this is considered to be a short half-life material. When you think about uranium, which has a half-life on the orders of a billion years or so. Now, this was of interest to creationists. And this is where the work was done on the analysis of the samples that I obtained. This is my alma mater where I went to graduate school. And that's a big facility, 3 million electron volts, and it costs $1 per electron volt. It's a $3 million facility. Very sophisticated. I looked at getting samples from actually 4 fields there. The Bravo Dome in northeast New Mexico, the Sheep Mountain up near Walsenburg, Colorado, the Elmo Dome over near Cortez, Colorado, and St. John's over St. John's, Arizona. 3 of those fields are connected via pipelines to the Permian Basin. And you see there EOR projects. EOR is Enhanced Oil Recovery. Nice thing about CO2 is you put it into an oil well, and you pump it in, and it raises the oil. And, oh, okay, now we can get it out a little easier. And then, of course, CO2 comes out with it. And they just separate it and put it back in the well. And, you know, it's good way to get most of the oil out of the well. And it's not very expensive to do that. Especially when you consider it costed like $1 billion to put that line in from southwestern Colorado clear down to Texas there. You say $1 billion investment says, hey, they know if this is going to save having to drill other wells and so forth, and they start amortizing all that out. I said, hey, this is a good deal. So, hey, I've got things right in my own backyard I can go analyze. So I did that. Notice the stratigraphic position. You've got Permian, Mississippian, and Cretaceous. Those ages are measured for those strata according to geologists. Those are measured in millions of years. So we're finding CO2 in materials that are supposedly millions of years old, and they're down pretty deep. Okay, let's go see what we've got. There we go. There's the results. I'm measuring it as percent of modern carbon. Now, modern carbon is about 1 point something or other. I don't forget the exact number. Parts per trillion in the atmosphere. And so you're measuring a percent of that. So it gives you an idea of the sophistication of the instrument to be able to measure parts down to a part of 1 part in a quadrillion. But it does it very well. The limits of the instrument are down there around 0.1. So you can see that the results are down towards the limits of the instrument, but not quite there. And I have one data point that sort of sticks out there like a sore thumb, where the rest are pretty well grouped. But notice that the mean value without that 1 point is about 0.36. And that translates to a conventional age of in the neighborhood of 35,000 years. Well, that's not anywhere close to millions of years. So I thought, oh, hey, looks like I might be onto something. So one of the Jerry Coryell mentioned that the book by the Rate book. One of the authors is John Baumgartner. John Baumgartner is one of the founding members of the Creation Science Fellowship of New Mexico when he lived here at Los Alamos. He did work on coal and diamonds, which, it's just simply black and white. And in that work, there's results of the data that he had gathered and that of Paul Geim that represents the Phanerozoic record, from the very young rock to the very old rock. And that's the distribution of carbon-containing materials found in about 91 different samples that were gathered out of the Radiocarbon Journal. Oh, okay. And you look at that, and the mean value for all that data is around 0.29. And, that's in the neighborhood of 35,000 years or so. And as Dr. Geim said, it's one of the best kept secrets in the world of carbon dating. It's sort of a skeleton in the closet. And it sort of fits because out there in universities and so forth, let's say I'm working in the physics department and I understand some things in physics and all, and there's some things that just don't quite fit with the evolutionary model. And we're working on it, it doesn't fit. But the guys over in biology, they've got it all together. You go in the biology department and say, they got a lot of things wrong here, but we just don't talk about it. Well, let's go over to chemistry and talk to those guys. Oh, yeah, everything's here just fine. Oh, got a skeleton in the closet? Yeah. And you go all around the different departments, and they talk about, all the wonders of evolution, but they have skeletons in the closet. Well, here's one that was in the closet of the radiocarbon people. They could not find a blank that was totally devoid of radiocarbon. Well, it's instrument error, processing error, so on and so forth, and dream up a nice story. Well, where do diamonds and coal fit in this? There they are. Diamonds being very old, coming from out of the xenoliths and so forth, and particularly in Africa. Hardest substance we know of. It's why they're very valuable. It's fun. Every once in a while, I'll see some lady with a great big diamond ring, and we'll strike up a little conversation. I say, your ring's radioactive. And it can lead to some very interesting conversations. So John Baumgartner did the work on coal, and he found a value of around 0.25 or so for the mean value for coal. So I was very encouraged by that. There could be carbon-14 in coal bed gases, which we have up here in northwestern New Mexico. And so there were several ideas on how the CO2 and the methane could originate coming out of those wells, and there were the authors. And they thought, well, we can get methane out of methanogenesis. You look at the roots there, methane origin from methanogenesis. Carbon dioxide by bacterial oxidation of hydrocarbons. Bacteria doing some work. So you say, well, if there's a carbon-14 in a coal bed, then shouldn't there also be some in the gaseous byproducts? It's sort of logical. Well, let's go see. And the answer is yes. Bed bugs make radioactive gas.